let's go ahead and get started. This is gonna be an interesting stream for sure. Gonna be working on an electric surfboard. I mean, living this close to the beach, it was only a matter of time, but it's still pretty cool. Alright, let's see. What's my chat? Alright, let's do it. That's why he was at the beach, you see? Stanley's thinking, man. That's right. That was the foreshadowing. Because I'm going to be working on an electric surfboard. Even though I can't surf, though. Not a surfer, though. Not a surfer, though. That's why I'm rocking the tank top today in my usual fit when I go. I mean, I got the chanclas on. I got the chanclas on. Sounds interesting. Yeah, man. I did not expect to get something like this. This thing is pretty crazy, actually. It's kind of dope. Um, it was a customer. He heard about me from a friend of his who has never been a customer of mine. Yeah, Sapots. You're right. You're right. I gotta rep the Zoes. Gotta put Zoes on the map. You know what I'm saying? We call them Sapots. Here, let me text the customer and just let him know if he wants to tune in. Even if he can't, you know, there'll be the VOD. Electric surfboard. Alright. That's kind of crazy. I feel like I should play like beach music, but I don't know any like ad-free beach music playlists, so this is the best I got for now. But we'll just keep it pushing. All right, so let's go over to the overhead cam. Oh, customer responded. Let's see what he says. Nice. Oh, he's in. Okay, cool. All right. So first and foremost, just to give everybody an idea of what we're working on today, because it's not video game related, it's a little bit different, but as you know, I work on all electronics. I pulled up a window to kind of showcase what it is briefly, so I'll share my screen here and you guys will see it. So essentially what this customer brought to me is an eFoil. You know, whenever they put a little E in front of something, you typically know it's for electronics or an electric version. So essentially, from what I understand, it's like an attachment to almost a small form factor surfboard, similar to what you see here. And then from there, it stays underwater and allows for propulsion. I'm not sure if you need to like move with it, because I think in the past there was foils where you kind of basically had to move up and down. Oh, you've seen guys at the beach rocking these. Okay, so you've seen these before. Yeah, it's pretty crazy. So the company's called Lift. Never heard of them before. Even though, you know, I live so close to the beach and I know quite a few surfers, I never really got hard into it before. I tried to dibbled and dabbled a few times with surfing, but it's never really been something that caught on for me. I prefer to longboard, stay on the ground. No surf and turf, just turf. But no, this thing is pretty cool. So essentially, I believe it's the Lift 4, and one of the attachments for it, water breached it. So what that caused was for some corrosion to exist. I'm trying to see if I can show you guys the exact attachment. Yeah, it's this portion that I'll be working on, the E-box. So apparently like water breached the gasket that they have, the seal here, and so that caused corrosion and some components to fail. So we're going to take a look at it. The customer already sent me pictures of some of the blown components, and I already spent the time to like order them. Oh, my bad. Forgot to switch the cam. So actually, let me go get those extra components. I ordered them off of DigiKey. There was plenty in stock. They just took a little while to get here. So I have the components here. There's some solid state relays. That's what blew. And also, I finally got a monitor for here. It's not big enough to basically see the chat too. Oh no, yeah, it can. It could work. Alright, so I can view the chat here, which is pretty cool. So I don't have to like turn my neck all the time. I'll be less likely to miss a chat comment. So typically with moisture components that don't do well in high moisture environments, considering, right, this is an electric surfboard, so you think it should, right? A lot of times they'll package it with almost like basically stout silica gel or an equivalent to remove the moisture from the packaging, especially for any moisture sensitive component. And these things are pretty tiny. They're a lot smaller than I thought they would be. But I ordered 5 just in case, just to have extra, because this project is going to be pretty collaborative with the customer. We're going to have to go back and forth and test some things, but I really want to work out a solution that could work long term. So I'm just trying to separate these things. That's why I'm shaking them, but they don't want to separate. But anyway, this is how small they are. So we have the new components. To stay on theme, that's where I showcase this, like, you know, turtle and some seashell items that someone made at some point in their life that somehow ended up. I love that. That's awesome. Thanks for sending that, Daph. So anyway, let's get this thing popping. I think this is going to be probably one of the coolest repairs. Funny enough, I'm not nervous at all working on this thing, even though I've never worked on it before. Because at the end of the day, if it has electrons running through it, it has to follow certain principles. So here's something that's interesting that, you know, is always funny, and I always laugh at these, is like these notices to not open something and warranty void. I'm like, I'm sure the warranty is already void. That's how it ended up on my workbench. But at the same time, I don't care about those anymore. So here's just the screws for them. So we have a push button that is attached here. I'm gonna separate it from the main circuit board, and I'll show you guys in a second. Sorry, right after I detach this. Okay, so now we can get this top panel off. Excuse me. This is just the push button, and then the wiring that was going to this board, it connected right here. Yeah, once that salt water got in there, man, it really did some damage. Salt is very corrosive. And as you guys may know, electronics do not like salt water. So anyway, from the factory, I guess they put this packaging in here to, again, help with moisture, to keep moisture out of the device. But I guess it just wasn't sufficient enough. But yeah, you can see once the salt water got in the device here, you can see it started corroding the threads on these ports. Let me see what these ports are for. I'm not sure if they're... Yeah, they're definitely electric lines, right? Because you see these thick gauge electric wire being ran to different sections. Oh man. This is what the customer pointed out to me already, is over here in this corner, you can see a good amount of corrosion. Let's see if you guys can see that. It's pretty gnarly. It got pretty rusty, and I think that's what broke a wire. Broke a couple wires off of it. Thankfully, one wire is still attached, so I know which one goes where, which one's positive, which one's negative. So let's go ahead and get started. I think the first thing I want to do is remove the PCB and do a full visual inspection. And I'm going to highlight some areas of damage which you may have already spotted on the board. Actually, before I do this, as I typically like to tell you guys, I like to take pictures so I know where things need to go back to. It's always good to take pictures of what you work on, especially it's not like it's something you can just go online and find schematics, right? Because this is something that's in circulation, so manufacturers aren't gonna have that be leaking on the internet. So go ahead and take pictures so I can remember how things need to go. If I ever need to refer back to it, I can. Alright, let's proceed. Let's get that back on the charger. We're gonna need to reuse this. In fact, I might add some more. I think I have a couple laying around. They just come in the packaging of many things. Get my gloves on. Alpha in the background. Nice. Hey Dad, nice to have you here, man. Alright. And as you guys may have noticed, on theme with the surfer vibes, that's why I'm wearing a tank top. You typically wouldn't wear a tank top when you're working on electronics. Shouldn't have this much skin out. I'm even wearing my sapatos. I got my flip-flops on in the house, which is typically a no-no for me. I don't wear shoes in my house, but that's alright. Gotta stay on theme for today. Okay. Hey, hey, hey. Uh-oh. Is that like a Fat Albert reference? I forgot about that show, man. Jeez. Forgot about that character. I wonder if that's not politically correct to say anymore. Alright. Just removing these connections now for anybody who's joining in. Trying to be as gentle as possible not to damage anything. I don't think there's going to be enough clearance there, unfortunately. I wonder if I can loosen this. Don't have the grip strength to do that. Wow, that's crazy. Not every day you have to work on something that requires you to get tools from your garage instead of just tools that you have lying around. If anything, I'll remove the PCB. In fact, let me do that. I'll remove this PCB, and then we'll detach this connection because I can't do it right now because this thick gauge wire is in the way. I see the guns are out today. Yeah, Dad. I'm wearing the tank top today to be on theme because what I'm working on is an electric surfboard, essentially. So, you know, I even got my sapatos on, that's what I was saying. I got my my sapatos, my flip-flops, whatever you want to call them. We're Haitian, so we call them sapatos. Alright, so these look like hex screws, and they look pretty small. Oh, need to go one smaller. Cool. Look at my light. Oh, see, that's smart. They used a metal that's not magnetic, which means that these are some alloy to probably help with like corrosion. So this material probably doesn't corrode as easily. That's probably why they chose to go with something like this. Yeah, Dad, I tried to be interesting, keep it on theme for the repair this time around. Keep these screws. You know, one thing I was talking to the customer about that I found very interesting at first glance when they dropped it off to me is that they did not use conformal coating on this PCB, which blows my mind. So for those who don't know, or not familiar with electronics, conformal coating is basically like a spray you put on top of your board or any PCB that creates a barrier for moisture, to keep moisture and contaminants out. And for something like this that's gonna be spend so much time near water, it's shocking to me that they did not use conformal coating on this PCB. I'm guessing that this device here is some type of antenna. I'm not sure if this thing can receive updates or not, or connect to Wi-Fi, but that's what this seems like to me as an antenna. Excuse me. Still getting over whatever I had. Well, I know what I had, but yeah, still getting over it. So let's go ahead, now that we can have full clearance to remove this connector. Let's do that. Try to be as gentle as possible. Alright, there we go. Perfect. So we're going to work on this later because we need to reestablish these connections because of the corrosion that occurred in this bottom right. You can see the salt. Like, the salt crystals are pretty sizable. In fact, I wonder if I can show you guys this under the microscope, just briefly, so you see what I'm talking about. The level of corrosion is pretty intense. So one moment as I position this, and then I'll switch over to the microscope cam view. Let's do that now. Okay. So let's get a deep dive as to what I'm talking about. So here's a contact point that needed to be made. I know it's pretty narrow view, but that's what happens when you have high magnification. So this is a broken wire. That's what this is when I'm moving. See if I can get that in. So this is a broken wire. As you can see, it's red. I know it's super blurry, but that's because it needs to attach to what's down there. You can see the level of rust that occurred because of the salt water, and that was a terminal that was made. So somehow I'm gonna have to clear off a spot on this bare metal, hope that it's still making continuity, and I'm thinking I'm just gonna solder it and then use RTV to make a seal of it. But the corrosion is quite intense. It's like actual just rust. So anyway, just wanted to show you guys that briefly so you can see what we're working with. So that's another issue that we're going to have to figure out. So there's corrosion on that section of the device, and then we also have to do some work on the PCB, which I'll show you guys now. For those who don't recall, PCB stands for printed circuit board. That's what all these electronic boards are called. Alright, so let's take a look at this guy. Here's the PCB. And you guys could probably see what went wrong there. So who can point out, who can say in chat what exactly happened? And I'll put it in dead center of the screen and just keep getting closer. Do you guys see that? Last time I checked, electronics don't like heat. So if something is showing some charring, it's probably not a good sign. So let's look at this under the microscope. Let's take a closer look at this. Oh yeah, fried. Yes sir, you said it. And not the good kind either. You know, this day in first world countries, people fry everything, but this is one of those things you don't want fried. So this is that relay that I purchased 5 of to replace this, and hopefully it didn't do any more damage to the board itself, like at the trace level. Hopefully the issue is localized to this component. Because sometimes when components blow, and something like this, that means it got too much power. What's going to happen is sometimes it could damage some of these traces too. So you're going to have to reestablish connections if those connections were lost. So obviously something obvious that's bad, but since I have the board here, I'm going to go ahead and just do a complete visual inspection of the whole board. Why is this rotated so much? Let's straighten up the camera a little bit. Okay. So far, everything else is looking okay. It still blows my mind that they didn't use conformal coating. That's just, I don't like to disrespect other engineers or what people come up with, because there could be a variety of reasons that they didn't. I'm still doing research to find a conformal coating that I think would work well on something like this. So once I figure that out, I'm gonna go ahead and try it and spray these components down, because not often, at least in my day job, when we have to use conformal coating, we never really have to worry about high levels of salinity or salt content. But overall, from what I'm seeing, board looks good. Board's looking good, except for that one spot. This FET looks okay. There's no major corrosion. There's a little bit of something here. Hold on, let me flip it over. Okay, I think that'll clean off easily with some alcohol. Oh, again, here's that chip I was talking about, that I'm pretty sure is used for some type of cellular connection or Wi-Fi connection, maybe for updates. All those solder joints look good. It's another thing. I don't know if any components that were in the circuit of the solid state relay right here could have potentially Dad said extra crispy please. That's funny. Maybe some resistors, excuse me, in series with some of these pins got damaged. So I'm gonna do my best to try to figure it out, because again, in this world we don't get to work with schematics from manufacturers because nobody wants to reveal their secret formula, right? Alright, so let's go back over to the overhead cam. Uh-oh. Got another alert. Hey, we got a subscriber. Thank you for subscribing. Appreciate it. Alright, so another thing I'm going to look at is the connections to make sure there's no corrosion there. So we'll go back over to our overhead cam. And we're going to try to look at the connectors. Well, not try, we can. Let me bring... Okay. So the side-facing connectors look okay. This looks fine. No corrosion at the pins. This one looks good as well. This one as well. No major corrosion at the pins. And this one's good too. No corrosion at the pins. This is all good stuff. Good. Alright, so let's go ahead. Just to for starters, let's go ahead and replace. Hey, it's Austin. Yo, what's up, man? Dang. Austin chatting for the first time. Let's get that boy to Wolfpack Wave. Welcome, man. Nice to have you here. You decided to stop by on one of the more interesting repairs that we've had. Granted, they're all cool, but this one is the most different and off-brand, quote unquote, because it's not video game related. Working on the electronics of a electric surfboard. And we have a fried relay right here. Man, that thing literally disconnected from the board. Do you guys see that? Well, yeah, let me show you guys what I mean. Somehow this thing blew up and disconnected from the board. I guess it was enough force or it got hot enough to disconnect. Here, like this back pin, it's a little dark, but this pin right here where my tweezers are touching, it's no longer touching the board. Can't even push it. Oh, well, that leg was just fried then. Yeah, it was fried. Okay. Let's go ahead and get this removed. So for something like this, because I don't know how much heat the board can take, I don't want to just use hot air right away, especially with something that is exposed to moisture. Excuse me. What happens is if you apply hot air to a board that absorbed some moisture, it'll delaminate a little bit, and you don't want that. That's when the layers of the board start to separate, right? Delamination. So we don't want that to happen, so I'm going to try to do this with my soldering iron. Excuse me. Honestly, I don't even know. This thing is only connected by like that one pin. Okay, so these two pins are not connected. These two are. So let's go ahead and get some flux on the board. Sorry, let me get that in focus for you guys. Here we go. So I'm going to work on these two pins here. Just going to apply some flux to get rid of contamination. And I'm going to use solder braid. That John Wick is what I like to call it, or what we started calling it at work. Or we just call it John for short. It's actually called solder wick, or copper wick, or copper braid. It has multiple names. This just allows you to remove solder from a component. Alright, so that looks good. We're going to do the same thing on this other pin, which is where I'm guessing this is the pin that really got hot. Okay. Lift that one up, lift that one up. Alright, we have the blown component removed from the board now. Tweezers are fighting with me. So let's take a look at it closer. The blown component. Oh yeah, look at that. Sorry, let me get that in frame. The thing completely blew open on that side. So okay, thankfully we already did our research beforehand and we have a replacement. So this component is definitely failed. But you have to remember something caused that to happen. And I think it was the corrosion that caused that to happen. So let me do my best to remove some of this charring off of the board. Just gonna lightly scrape it off and try to make sure there's no damage, and then I'm gonna come back with a swab soaked in alcohol. And then we're also gonna remove the old solder as well. Excuse me. Alright. Yeah, I'm curious to get this, after replacing this part and making those connections back, I want to see if that's enough to restore functionality. So I'm going to bring it to or ask the customer to pick it up and test it. Maybe even if he could bring the connecting pieces with him and they can test it in front of me, or like, you know, at my workshop here. So we can see exactly how it, or I can get a better idea of how it functions. But thankfully it looks like just the component failed. Hold on. I need to move you guys over here. Thankfully it looks like just the component failed. I'm not seeing any major trace damage, which is a really good sign. Extremely good sign. Alright, so let's clear up some of that old solder to the left here. And then we're going to put down a new one of those components. And then I'm going to put this PCB to the side, and we're going to work on the corrosion where the water breached. We also need to figure out some type of new gasket method, because obviously that original gasket failed. Let's get some of this old solder off. This must be a ground. This connects to this resistor. This trace goes here to this connector. This trace goes here to that connector. Okay. I think something caused that relay to short to ground. From what I'm seeing, it's the only thing I can assume right now until I see more or get more information. We're gonna go ahead and clean that up. Excuse me. And I already got my grinding pen ready to go to remove as much of that corrosion as I can. I'm curious if this relay, because there's two of these relays on the board. Here's the second one. I wonder if this one is starting to go too. There's no signs that it's bad. I kind of want to just replace it since I have the extra components. Because I'm pretty sure it uses the same. I mean, obviously they would use the same relay for both. Yeah. You know what? While I'm here, I'm going to take some measurements for my own records. Just so I know what that resistor going into. Excuse me. And I'm going to go to the overhead camera so you guys can see the meter. This guy. Oh, let's get it in frame. So you guys can see the values too if you care to. So I'm measuring across R34 and we get 1K. So that's a 1K resistor. I'm assuming they both should be 1K. Yep. And they're pretty accurate too. So I'm going to write that down for my records. 1000 ohms. My pen. This is the nerd stuff right here. Let's see. So one was R34. eFoil. This? It was an eFoil E-box. It's a Lift 3 E-box. Lift 3 E-box. R34. Hey, that's one of my favorite cars right there. R34. If I ever make it big, I'm definitely gonna have that car. Okay. R2 is also a 1K. So, excuse me. The reason I measured those is just to make sure no degradation occurred from the relay failing. Is that typical? Not really, but since I'm here, I can just measure it just to get a analysis done of it, of the integrity of the board. And like I said earlier, everything else looks pretty good. So we're gonna go ahead and get the new solid state relay soldered down here shortly. Okay, so that's all ground, so that's fine. Alright, let me get my meter out of the way. Okay. New components. Gotta love them. Let's go back over to the microscope view. So this is what we're soldering to. So I'm just going to compare the part number on the one that was already installed with this one. So we have CPC 10179, which matches up with the component that was already on the board and matches up with the one that was blown. Just something to do. I mean, you can pretty much trust that these vendors send the right parts, but I like to double check just to make sure. Now, for those who are tuning in for the first time to one of my streams, how do we know we're putting the part on the right way? How do we know it's supposed to go this way and not this way, flipped around? There is a way to actually know. In the electronics world, it's called, do you have, Wolfpack Electronics Dad asked, do you have a schematic for this thing? Absolutely not. Of course not. Like I said earlier, most manufacturers don't want to give up their secret Krabby Patty formula. So just to state, how do we know the part goes one way versus the other? Well, you look at the board. This little mark on the board, right here, where my tweezers are, in this bottom right-hand corner. This is an orientation mark. This lets you know which way the component needs to go. And on the component itself, this right side of it is beveled. So that bevel needs to line up with this mark on the bottom right of the board. So now that we know that, let's go ahead and get this soldered down. Add some flux. Add some solder. And then we will get it into position. Once you have one leg down, you can pretty much go to town on the rest of them. Rotate it. And then we're going to do these bottom two. That's soldered good. That's soldered well. And that's soldered well. Go ahead. You know what? While I'm here, I'm going to replace the other one too. The other relay. Kind of using the headlight logic. If one bulb goes out, your other one's probably going to go out too. Could be a fallacy, but I'm already here. Okay. So that one is soldered in quite nicely. And I will clean up the extra flux in a moment, but I think I'm just going to go ahead and replace this one, and then I'll clean them up. organized here. Cut this off. But yes, for those who tune into my Instagram story posts, this is why I was at the beach. This is the foreshadowing. Granted, the waves kind of sucked today, so there were no surfers. In my head, I was hoping to get a view of people surfing. But at the beach I was at, in particular, there was nobody surfing. There was literally no waves. It was so flat. Super flat. Oh, lost it. Alright, we're gonna remove the solder from these two pins now. That removed quite nicely. Moved quite nicely. Alright, so now let's see about trying to get that last bit of solder to get it off the board. You know what, since I'm not going to be reusing this, I'm going to try to lift the pin as I apply heat. Lifted. Alright, that one's lifted. I'm gonna do the same thing on the other side. But Dad, I wish I could find schematics for this thing. But the circuit is actually pretty simple from what I'm seeing. Like, it's not a super dense circuit. So if someone really wanted to, you could just reverse engineer and make a schematic, take all the measurements, and then write it down. It's a tedious process to do something like that. Trust me, I know. But maybe it could be something if, like, you know, if the eFoil community needed it or something, I could probably do that. Alright, let's go ahead and clean this off, and then we're gonna put a new solid state relay in its place. Was that relay bad? I doubt it. It didn't show any signs that it was bad, but while I'm here, might as well replace it. Also, if I'm able to figure out a solution for this, I feel like it would do well for people in this community who are, like, you know, surfers who have an eFoil that may be outside of warranty, and it might be really expensive to get it fixed with the manufacturer. And I doubt there's many people working on these. And if they are people that work on this, it's probably like a very niche person. Probably like a few people. Because it's already a product that's pretty niche. Like surfing, right? You gotta think of places in the world that have enough water and nice waves next to them, or who live by a beach in order to surf. That's not a huge demographic, right? And then on top of that, this product is not like the most inexpensive of products. And for someone to be that level of enthusiast to want to invest that kind of money in this product, so considering all those things, I doubt there's many. I mean, I'm sure there's somebody, but I doubt there's many who work on this. Alright, let's go ahead and get the ground pin soldered down. And let's go ahead and get this in. Hold it in place. Nice. I made it! Did I miss any tests? No, you did not, Crash. Crash made it. Oh my goodness, it's Crash. She is hither. Woohoo! Yes, we're working on an electric surfboard, or one of the components of an electric surfboard. Pretty cool. That's why I'm on theme. That's why I'm wearing a tank top. I'm not trying to show off my hard training, the works of my training, like Krillin or something. Oh wait, wrong thing. Alright, so we're gonna solder a leg on the opposite side real quick. And then once we get this board, this component soldered in, we're gonna work on the corrosion issue. See what we can figure out there. I even have my sapatos on. For those who don't know, sapatos just means like sandals in Haitian Creole. So I have my sapatos on. On theme, in the house, which I don't wear shoes in my house. Hey, we got another alert. Welcome to the pack, man. Appreciate the follow. Alright, let's give this thing some flux and just touch up those solder joints, and then I'm going to go ahead and use a foam swab to clean that up. Alright, I'm cool with those joints. Tin my tip. Alright, let's go ahead and clean off this PCB, and then we will tackle the corrosion issue. Alright, let's get rid of this excess flux. Looks good. Give it a nice little brush to get some of the fibers off of it. But thankfully, everything looks alright. Oh yeah, I did notice that little bit of corrosion there. Let me give it a quick wipe. That's just from the salt water. Thankfully, it didn't do any real damage there. That's got to be one of one of the toughest things to deal with for a device that's going to be submerged in salt water, you know? Cleaning around this capacitor. Now we have another spot of corrosion. Okay, second. Thankfully, nothing crazy. We're gonna go ahead and get that cleaned off as well. There's a little bit of corrosion here caused by salt water. You know, think of it similar to like when you had a Game Boy and you leave the batteries in too long and it causes that corrosion on the terminals, which can prevent it from working because the electrons can't flow through corrosion. Same thing. Same thing. Alright, let's go back over to the overhead cam and let's start taking a crack at the larger portion of this device. But I would say the board has been restored, at least from what I can tell. Functionality I won't know because I don't have the rest of the components that attach together. The customer still has those pieces, but I'm definitely going to be working with him in the future to try to figure that out. And I told him that up front. I was like, it's not something I work on every day. We're going to have to collab on this if you want me to work on it. And he was like, yeah, sure. He was all for it. I was like, all right, sweet. Sounds good to me. All right. All right. Alright, so the PCB, I'll consider that good. I'll put that in an ESD bag. Put it in this bag with the components. That way I know it's safe. These are the damaged ones that don't work that I took off the board. I'm gonna put those in there. And then the new components, put those in there. Oh yeah, Crash, I'm gonna have to give you the bad news now. I won't be able to test this now. This will be a long-term testing endeavor. Oh, there's another PCB underneath this one. So that's just that PCB. Okay, how am I going to get that out? Okay, so no screws are exposed from the bottom here. I want to get that out so I can have enough room to work on the corrosion in this corner. So. I see a screw here, 4 screws holding it down. The other thing is though, I think I'm gonna have to go ahead and get my wrenches. Holy moly, I'm gonna have to go get some wrenches. Alright. Do I have a set I could just bring? No, all my tools are loose at my garage tool chest. So I'll be right back. I'm just gonna go grab some wrenches, because I don't typically keep wrenches at my workbench. So what is this thing a part of? Is it a controller or what? So I guess it's just the electronic box for this, good question, Dad. Here, let me show you. Let me show you guys. I'll share my screen. So this is the box. Oh, see, look, this is the RF antenna for that. The PCB, what I was saying, looked like an antenna circuit or component. That's why. So this is the brain for the eFoil, which is that electric surfboard. He had the Lift 3, I believe, which I'm guessing they're starting to phase out. But essentially, it's just an electric surfboard, Dad. That's what it looks like. I'm guessing these are components that attach within the surfboard itself. Let me see if I can pull up a Lift 3 boards. But this is functionally how they work. You literally have a board and there's a component underground that propels somebody. The two of them for IHOP? That's funny. But yeah, Dad, that's what it is. It's essentially an electric surfboard. But like I said, I gotta go and grab some wrenches, so I'll be right back. Don't go anywhere, I promise. I'll be right back. I'm just gonna head to my garage. I'm probably gonna, let me bring this with me so I can just grab the right tool once instead of making multiple trips. And I will see y'all shortly. In fact, I'll just keep you guys on comms because I have my headset until I go out of range. Oh wait, what time is it? Ah, that means my alarm's on. Okay. Okay. Wow. Never thought I'd have to grab wrenches. That's different. It's fun. It's cool. Okay. Let's see. 10mm. Perfect. So we got a 10. Alright, I'm heading back. I got the correct wrenches I needed. I needed a 10mm and a 14mm. Boom, and boom. Oh, close the door. This is what we have. 10 and a 14. So the 10mm is for these electrical connections. And these thick wire gauges, I'm gonna need to move them out of my way. Alright, so this is wanting to spin the whole thing. I didn't think about those. Let's see if this will work for this too. No. So there's lock nuts on the back end. Darn it, I brought this thing so I didn't have to make multiple trips, and in the end I have to make multiple trips. I'm sorry, y'all. I'll be right back. I need to find something to prevent the counter spinning. No, not a quarter, half inch. That's what I meant. Okay, 17. That might sound a little distorted because I'm in my garage, but like Ty Lopez in my garage with all my knowledge. Okay, got a 17 millimeter to kind of hold this back nut in place. That's funny. Alright, so we're just basically, this is going to be here to kind of hold it in place to prevent it from spinning while I spin this guy. There we go. Bit of a pain. It's a very tight workspace. Alright, so now that the nut has been broken, we just got to do that 2 more times. The real Gote, there he is. Jeff, what's up? Hey, Gote, how you doing, man? Good to see you. You know, I was just thinking about Keyshawn, and then you pop in. That's funny. What's that Buster doing? Electric surfboard looks interesting. It sure is. I'm definitely excited. I love working on new stuff, man. That joint gets me going. Like, you know, it's cool fixing controllers and HDMI ports, but this is the stuff that's fun. At least to me. Some people, they don't like working on new stuff, but me, personally, I like it. This is what I did for years. I mean, I still kind of do it to some degree. I build test boxes similar to this. I built train simulators before, that model a whole train, built all kinds of things. Alright, so these two, and we have a few more, or one more to loosen up. And I already took pictures, so I know everything goes, so I don't mind just continuing forward. Alright, we're gonna hold this locking nut in place, just like we did already, and then crack this 10 millimeter. They're a little harder to crack than I think they should be, and it's probably due to a little bit of corrosion getting in there. Yeah, you can feel the salt grinding as I spin it. That's alright. I'll figure out a way to get that salt off, that brine off of there. You work on VR headsets? Crash Goes Trains! Key looking for a camera for me. Oh, okay. Do I work on VR headsets? I haven't worked on a VR headset quite yet. No. I'm curious, which one? And what is it doing? Is it like a blown speaker, or one of the optical sensors not working? Okay, so this gets this out of the way. So I should be able to lift this out. This is probably going to block me. way too big. And then this is too small. Are they both 14? So this is 14. So I'm loosening this up, this nut here, in order to be able to thread more wire inside the case to create more slack for when I need to get this out of there. Oh, this is pretty good at keeping water out. I like what they used here to keep the moisture out from seeping in through these threads. They basically use nylon, which you can press into whatever form you want it to be. You know, salt water is conductive. That may explain the crispness. Precisely, Dad. Salt is an electrolyte. That means it carries electricity. 100% agree. Alright, let's push these wires back through to give us more slack for when we loosen this board. So yeah, it's a real thing, guys. When they say drink your electrolytes, it's real. Those certain minerals are conductive. For those who may not know, if you have a glass of water, of ice water, if you want it to get colder, you can just add salt, and it will get colder. That's a fact. Okay, so I use this one. Of course, it's only one size larger. Let's see. Science. Dropping some knowledge. It would be easier to show you rather than tell you. Okay. I'll have to coordinate next time I head over to 526. Alright, let's get this out of the way. I think it's just these 4 screws, and then I should be able to get this second assembly out of here. And for what I can tell, I don't know if it's a battery underneath here or what, but there's all these components going to it. Okay, how am I gonna get that off? Let me see if I can just crack these. No, that's way too big. 17. Nice. Tightening it. I'm gonna have to loosen up these hoses in order to again create more slack as best as I can. I might need to remove these fittings. That's annoying. I was hoping not to have to remove the fittings, but I might need to. But Gote, he's looking for a camera for you. Why you need a camera? And what kind of camera? Like a DSLR or a webcam? Now you got me curious. Alright, I should be able to snake this back a little bit. Yes. Giving myself more slack. So that's the fitting. That's cool. I like that fitting. For preventing water from seeping in. That's pretty cool. I gotta give it to him. That's a cool fitting. That thing really clamps down on it. Oh, actually, I could probably remove it from this end. Yeah, I really don't want to. Oh, I see. I bet they're using the salt water to cool it. Because it looks like this just water runs in. I don't know if you guys see this. Here, I'll point to it. Watch my finger. Water comes in from this hose, goes along this rail, I'm guessing cools it off, cools off whatever's underneath this metal plate, and then exhausts from this pipe. So we have an intake of water and then an exhaust of water. That's cool. That's smart. You know, reuse your environment to cool your components down. Ooh. Alright, let's take a look at... Oh, that's not good. Ooh, that's not good at all. That was just the one PCB. I think we're gonna have a lot more damage on this one, unfortunately, because the water filled up the bottom of the case from what we can see here. And yeah, I'll show you guys shortly what I'm seeing already. This is gonna require a bit of a rebuild. Alright, let me get these screws out so I don't lose them. Tweezers. Okay, we got the 4 screws out. Let's see, we have a new follower. Welcome to the pack. Appreciate you being here. Okay, and then we have this cable connection. So we have 1, 2, 3. Trying to see what's preventing me from removing this more. And if I even need to, I might be able to just create enough slack where I don't need to remove it entirely. But I don't want to put too much strain on any of the connections. Alright, I think we're at a point where I want to take another picture for reference data. You know what's funny? I just realized the shutter sound on that kind of sounds like a TIE fighter from Star Wars. I don't know why I just realized that. Sounds like a TIE fighter shooting its blaster or whatever. Or cannon. There's so many words for it. So this is left, right, mid. I kind of want to mark these. So we have left. I need to mark one more. This was mid. This is right. Yes, let me just mark this too. Oh, so this is just for this connection here. Okay. Alright, I'll just have to figure that out. Okay, and this connection goes there, so I don't have to worry about this guy. He can stay. This is good. Let me see if I can flip this over to show you guys exactly what I mean by I think there's going to be a little bit more corrosion than we initially hoped for. Okay, so this board they used conformal coating, but you can see the corrosion that occurred. I don't know if you guys can see that next to where my finger is. It's pretty bad. So it looks like the USB-C port is completely corroded. We have a FET that's corroded here. Right here, this one is pretty bad. So this bottom assembly took the brunt of the hit, and I'm guessing this failing caused that relay to fail when it switched over. That makes sense. And this is what I was talking about, is like something caused that relay to get crispy. And my dad pointed it out too. You know, salt water is conductive. And that's probably what caused the crispiness. Lol, Bolo's watching Star Wars right now. That's funny. Tell Bolo I said hi. Okay, so they use a gasket. Okay, so I'm going to need to get this fitting off in order to get this whole assembly out. So let me get rid of these clamps here. Get one of my favorite tool of all time. These like very fine point needle nose pliers. Alright, cool. And then we need to do the other one. Oh man, that is on there. It's like pick your poison. Which one do you want to take off? It's like you either take it off here or you take it off at this fitting. But I'd rather leave the fitting alone. Gosh, this is starting to remind me of like working on cars now at this point. So we got the hose clamps slid down the hose, so we should be able to remove these fittings if they will give, if they will let us. Oh, these things are tight. See, what could I use? Let me try a very flathead screwdriver. Try to pry it a little bit. I want to get under just enough to loosen it, but you don't want to damage the hose or the fitting. Just got to be patient and work with it. You don't want to damage it. You know what? I think I have hose pliers in my garage. I wonder if those would work for this. I don't see why not. A hose is a hose. You know what? I will be right back. I have a pair of hose pliers. I'm not allowed to fix things. I vote hammer. Sorry, Crash. This is one of those times we can't use hammer. As much as I love Mario Brothers and like Mario and Luigi series, love the hammer. Can't use the hammer. I'll be right back. I'm gonna grab my hose clamps. Alright, we are back with hose clamps in hand. For those who don't know, these are for working on cars, but this is what hose pliers are, essentially. So as you squeeze, it squeezes around it to help you pull it off. I don't even know if this is small enough. Nope, it's not small enough. Dang it. This is the smallest size hose plier I have. That's unfortunate. Okay, let's keep going. Hair drying might loosen up without damaging parts. It's a good idea. They might be glued on to avoid leaks. Heating it, I vote hammer. Good points, good points. And Freddy Foo, this is your first time chatting, welcome. Didn't see it earlier. Say hi to you. I don't think there's glue, but that fitting is quite on there. And this is just one of two, so this is going to be annoying. It's going to be quite a bear. Okay, I'm getting some action here. We're getting some movement. I bet these iFixit guys, when they made this tool, they didn't think it would be used for this. Highly doubt it. Oh, there we go. Okay, so we got one fitting off. Fitting is intact. My bit is not intact. But actually, now it has like a scooped... It's like kind of scooped now. So that should help. It's a little scooped. Alright, let's see how well this helps with the second one. Once this fitting gets off, we should be able to get more clearance so that we can actually work on the PCB underneath. And we shall go from there. Okay. Let's see, where are our sticking points? Let me tuck this underneath so it gets out of my way. I have these thick gauge wires in my way. Not very malleable. Sure I'm not missing any guys. You only do electronics or open to different stuff? Definitely open to different stuff. Probably not on stream. For on stream, I'll probably stick it to electronics, but off stream, I'll work on anything. Anything, especially the more interesting it is. Like cars, let's see. Scooters, golf carts, anything. Why not? That would be cool if, like, in the future I can get like a whole camera set up in my garage. Work on bigger things. That would be cool. Oh, there we go. Nice. Careful. There we go. Alright. We were fighting with that for a little bit. Finally got the water hoses off. Hey, we got a new follower. Thank you. Appreciate you for joining. I was in Twitch. Hey, Gote. What you fix? What is that? Oh, hey, Jonathan Garcia. Working on an eFoil e-box. A lift eFoil e-box. Wow, I put W foil. Type in with one hand. Okay, so we just have these two connections that are preventing us from getting it outside of the whole board. I wish there was a way that we can disconnect it from these very beefy electrical connection joints. Guessing this is what gives power to some motor, to the motor for this thing. Don't see a way we can get that out. At least not from this end. From this end, looks like they solder it in and use RTV. Let me see if I can just work with it, work around it. Let me slide these back. Now that I have the grommets loosened up, I can just push this in, give me more slack. And I think I'm gonna have to work with it like this. So originally, I thought I was just gonna have to deal with this corrosion here. I'll show you guys closer up to the camera. This bit of corrosion that we have here. See if I can get the lighting better. You see the rust that formed from the salt water. You can see where it pooled, you can see where it stained. And that's ultimately what caused the failure of that top-mounted circuit board, where they didn't use conformal coating. And then I think also the failure of the bottom-mounted circuit board, which caused the failure of the relay on that top-mounted circuit board. Alright, so let's see about opening this thing up and taking a closer look. So from what I can see, this is nice. It does look like all the components are visible from my end, which is really good. That I'm really happy about. Alright, let's see. What do I need to do to take this off? So all these wires are soldered on. This is going to require some significant rebuilding. Okay, so we have a shorter capacitor. Actually, let me take a picture before anything gets knocked off. Try to be as gentle as possible. This is still super cool to work on. This is dope. Oof, that rust, exactly. This is Christian, the customer, by the way. Great work, man. I appreciate your help. Absolutely, man. Glad you were able to make it through. Nice to have you with us. I always like when customers watch the repair so they see exactly what goes on. Oh snap, it's Spectator 50 again. The lurking turkey. The lurky turkey, man. Came through with the gobble gobble. Pause. Oof, that rust. Yeah. Salt water, man. Salt water will do that to your electronics or to your metal, period. Alright, let's get a bit in this thing. Let me see. I think this bit is a good candidate. Oh, that is like already loose. I didn't even do anything. Or maybe it's spinning with it. Oh yeah, it's spinning with the whole thing. Okay, I was about to say, there's no way that should be that loose. It's funny, I can showcase to you guys conformal coding, what I was talking about earlier. And I'm shocked they don't do it on that red PCB, which we already replaced the component on. Okay. Yo, salt water does not care about your hopes, your dreams, how much you paid. It does not care. It's just like, rip. Okay, so they seem to be using these standoffs, which are a little bit of a pain, because I have to find a way to prevent them from rotating as I try to unscrew them. And they're nylock nuts, meaning because there's some lock nuts that have like almost like spikes that dig into the metal. So as you try to spin it, that's how it locks up. And then there's some that are like a plastic material that as you thread into the plastic, it basically holds the screw captive, and that's the style they are. Those are called nylock nuts because they use nylon to lock the screw in place. Just some hardware facts. Okay, I wonder if I can just use pliers for now, or am I needle nose pliers? Okay, this works. I can get this screw out of here. It's gonna want to drop. Okay, so we have one. Let me put this to the side. Uh-oh, my chat scrolled down. Spectator said, how does the coating affect repairing it? Harder at all? It definitely makes the PCB coating. Yes, this conformal coating, PCB coating, anti-water resistant coating, there's so many names for it. It does make it a little bit harder because you have to remove the coating in order to work, you know, on the electronics you're trying to repair. So it can make it a little bit more cumbersome. It's the best way I can put it. It's like, I guess like if you were someone who was trying to like ceramic coat your car, you have to clean it and get rid of impurities first. It's kind of like that concept. Like in order to do the job that you actually have to do, it's like the prep work. It's just more prep work to do whatever you need to do. It's the best way I can put it, or the best example I can come up with right now. Is that washer captive, or is it going to want to move on me? So they use plastic standoffs in between the two boards. I'm hoping they're just floating there. Okay, I'll deal with that later when I get the rest of them off. But good question, Spectator. Appreciate that. Yeah, and again, they did not use screws that were magnetic, because usually screws that are magnetic are also prone to corroding. So the screws made it. That makes anybody feel better. Okay. So right now I'm just trying to separate these two PCBs from each other. They went with a main board and daughter card design. I'm sure it's just for the space constraint. So I need to separate the two so I can get a better look at it. Okay, so we got these two standoffs off. Oh, this washer did not want to come with it. I'll just leave it there at this point. Alright, so we have another one here. I'm gonna have to remove this screw down here. So I'm gonna hold it with my pliers. And then unscrew it from this end. Thankfully, these aren't super tight, so it's not too much of a bear. Thankfully. Okay. And then we can get the screw out. There we go. I wonder if I can show you guys what I was talking about that plastic they use to hold. You know what? This is a good example. I want to show you guys just briefly what I was talking about earlier about the nylock nut. It's a different form of a lock nut. I'm going to show you guys. Get this in frame. Microscope cam. Alright. Where's my finger? It's like, follow my finger. Is this it? There it is. Alright. So right there. So this is your nut. Do you see that blue, that little bit of blue in there? That blue, what you see is a blue plastic called nylon. It's not always blue, but in this case it is. So this is what the screw threads into to basically preventing it from backing out from vibration or any other motions that happen. So that's what I was talking about. This is a form of a lock nut to prevent a screw from backing out on its own. Just wanted to show you guys so you can see it. We work with these pretty often in the rail industry because of all the vibrations of a train riding on a track. There's a lot of vibration. So, man, appreciate the follow. Thank you. What? Spectator 50 subbed. Dang. He subscribed with Prime. Thank you for the Prime sub. Appreciate that. That's what's up. So you're not just a lurky turkey anymore. He's actually giving out subs. Wow. 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 Like Owen Wilson or Luke Wilson. Wow. Alright, let me get my pliers here. We have, this is the last screw to remove the this PCB from the main one. This daughter card from the main PCB. Still super dope to work on. I can't believe I'm working on like the components of an electric surfboard. That's crazy. Especially someone who grew up like near a beach their whole life. You know, friends with many surfers. I know many surfers. I've watched them. They've tried to give me tutorials. Never really took to it. I do skate though. Like skateboard, longboard in particular. So it's still pretty cool to work on something like this. Okay, so I'm hoping at this point I could detach this daughter card, this smaller card, from the main card. So I'm hoping I don't get much resistance or something that's preventing me. Oh no, looks like there's board-to-board connections. Well, that's a pain. Oh, that's a pain. Oh, all of these are board-to-board connections. Okay. Okay, so we have these 6 here, we have these 8 pins here, these 6 here, and these 4 here, from what I can see, that are board-to-board connections. Alright, let's go ahead and turn on our iron, get those removed. I wonder if I could flip this over. It's going to put a good amount of dust on my workbench and rust, but that's okay. And salt, man, the salt crystals are huge. Shoot, some nice salt, man. Let's talk about sea salt, right? Some people like to season their food with sea salt because it's better for you. Yo, it's Air Studios. What's up, Unts? Electric surfboard. The future is now. Facts. I want one so bad. Do you surf, Gote? I didn't know you surfed. That's pretty cool. Man, look at all the salt it's leaving on my workbench. That's insane. That's pretty cool. Wait, what are these 2 screws I'm seeing? This one here and one here. Oh, that's the whole. This must just be a big old thermal pad. Oh, that's how they're conducting the heat. It's instead of a heat sink, they use the thermal pad. That's what this like material is that I keep having to rub off my gloves. It's almost like thermal grease, but in a pad form. So a thermal pad. You've probably seen these if you ever upgraded the memory on your PC or PlayStation. Okay. I'm gonna have to remove these solder connections. I'm gonna have to just deal with rust on my workbench. That's okay. I have a vacuum. I will vacuum it later. Oh yeah. Alright. That's okay. I need to flip it this way in order to be able to work on what I need to work on. Oh yeah, I took some components off too, so I'm gonna have to try to guess what value that is to replace it with. Honestly, as bad as this thing looks, I think it can be saved. Honestly, it's not gonna be easy. There's a lot of components that I'm gonna have to figure out what they are in order to replace them. You know what might be a good idea is to get a donor unit. Maybe one of these off of eBay that doesn't work. And then between the two parts, there's probably a viable option between the two. Yeah, that makes sense. I'll probably see if the customer even wants to go down that route. I think it's still viable because the cost to replace this is expensive. I mean, it's an expensive enthusiast grade item. Like, why am I turning that off? I need to leave it on. Alright, let me get my other glove. Oh, it's in my pocket. Let's see. No, but I can move to Florida and learn. I feel you there. You said, do you think unit like that is B2B connection, likely human or machine assembled? Do you think unit like that is board-to-board connection, likely human or machine assembled? I think at that point that's human assembly. He said, I repasted a few GPUs and those are littered with thermal pads. Oh yeah. I think for GPUs and like high level processors like that, what you're going to find thermal pads around is all the memory chips. Because those things get toasty too. So like actually on the GPU, the processor die itself, got you. I'm just playing. On the GPU die itself, it's going to be the paste, right? Your thermal paste, and then on all the memory chips surrounding it are going to be your thermal pads. And of varying lengths and thicknesses. So I know you probably if you've dealt with that, you're already a technically inclined person. Because that junk is annoying and it's a lot. Okay. So we're going to have to, I don't think I'll be able to show you guys on the microscope because of just the height that this board is at because of all the thick gauge wire connections. I'm going to do my best to figure out which conformal coating this is to remove it. Hopefully it dissolves with alcohol. Hopefully. I really hope so. If not, I'm going to have to scrape it off and get underneath, but we shall see. So let's focus on this section right here. Okay, of course not. Oh no, it is dissolving with alcohol. It's just taking a while because it's very thick, which makes sense for something like this. It's going to need a thick amount of conformal coating because it's literally going in the ocean. I don't know how much a more harsher environment for electronics there is than the ocean. That's about as harsh as it gets for electronics. Also, if my hat's getting in the way, just let me know. I'll flip it around. Alright. This is a tedious process, but I'm just trying to remove the conformal coating around these solder joints that I need to remove the solder from. Alright, let me turn on my big boy soldering iron. Let me see if I can view this. Actually, I might be able to show you guys. Let me see. Oh yeah, I can. Okay, even though it's at an off angle, it might get out of focus a few times, but it's okay. I want you guys to see what I'm doing. Times at 950. It's not bad. Okay, right here. So I need to remove these 6 solder joints. So that's what I'm going to work on right now. So as you guys know, this is my cousin Stanley's favorite favorite chemical in the world. I'm never going to stop saying that. It could be 10 years from now, I'm going to still say it. And he's going to be like, bro, I've never used that junk in my life. I'm like, it's too late. The meme has been created. It's already done. Always has been. I forgot about that meme. The always has been meme. Oh, it was already off. My bad. Oh, this is charged. I don't need to have this plugged in anymore. This was my grinding tool. I started charging it because I knew I was going to need to grind away the rust that was there. Alright, I just have to wait for my soldering iron to heat up. You know what? I've been wanting to repaste my GPU. I need to do that. See, now you got me inspired, spectator. I'm inspired now. I need to get ready to repaste. Alright, let's see what we can do. Where's my solder work? Alright, this is the one. Already added flux, so let's go ahead and see how well we can just remove the old solder. Okay, nice. That's coming up quite nicely. That's perfect. That's exactly what I want. Because of the awkward angle, I'm going to have to cut it off pretty frequently, the used wick, because it's hard to get a good angle to just keep using it and sliding it down. Maybe I can bend it in post. See, are you guys seeing it? Yes. Okay, good. I don't want to hold the heat on the pin too long because I know it goes to a plastic connection and I don't want to melt that. I just want to get enough heat to remove the solder from surrounding the pins. And thankfully, I like what they did here. They thought of this already. I'm sure someone has had to work on these before. There's ample space around these pins. You see how much space is around them? That's amazing. Spectator said, I worked with a guy named Joel, rest in peace to Joel, that was known for overusing dielectric grease. The term Joel butter was coined? Bruh. That's so funny because I'm someone who never uses that stuff. Actually, I think I have a tube of it. Yeah, I'm about to write Joel on it, bro. In honor of Joel. Where's my dielectric grease at, bro? Hold up, where's it at? Oh no, this is white lithium grease. I know I have dielectric grease. It's probably in my garage. I was about to name it Joel. I'm about to write Joel on it. In honor of Joel. Yeah, my dielectric grease is in my tube drawer in my garage. But the next time I get to it, I'm about to write Joel on it. That's funny. Joel butter. Alright, we got a few more connections we need to desolder. So let's go ahead and do that. Looks like we have 2 more. Thankfully, these aren't like, they don't take a lot of heat, so they're wicking up pretty well. Actually, I'm gonna have to approach it from this angle. It's awkward, but you gotta work with it. You gotta work with what you got. get my fine point soldering iron. Oh, it's not in frame anymore. Let's get it back in frame. Right there. Alright. I think all of those are loose, excuse me. And we're gonna just test that real quick by just doing a little push test to make sure that they're all loose, they're not touching, they could wiggle on their own. Alright, this one can't, this one can't. Okay, only one of them can. It's kind of a pain when dealing with these. If this was something like you work on all the time, I bet the factory and whatever technicians they have that have to rework these things, they probably have like a solder sucker, like a solder vacuum. So you don't have to deal with the solder braid method. Okay, maybe I can just hold them away from the walls so that that'll allow me to get this thing. It's good. Nice. Okay, all of these are loose. Good. As annoying as that was not so bad. Now we just gotta do that 4 more times. Okay, let's slide on over to the next batch that we need to do, which is way over here. You guys see it? It's an 8 stack. So just like before, I'm gonna have to use some alcohol to try to remove as much of the conformal coating as I can, so that makes it a little easier to work around. Now granted, the iron gets hot enough where it kind of burns the coating off, but the more I can remove with alcohol, the better. Alright, let me use my brush. Oh yeah, that's much more effective at breaking it up. Yeah, it's like clumping it off. Perfect. Actually, that might just be old paper. Alright. Okay. Let's go ahead now and remove these connections. I promise. It's gonna get interesting. I promise. And I think I didn't realize that there's gonna be this kind of corrosion underneath. We're probably going to need to do like a part 2. I might even work tomorrow. Who knows? I don't want to put that out there too heavily, but I might just do it. Shoot. Why not? Get a few hours in working on this. Okay. It's so cool watching solder like wick up into copper braid. It's one of the cooler things to see on this planet. It's just very satisfying. It's very satisfying to watch. Alright, let me change my angle of approach here. Little out of frame there. Let's get you back in the frame. Right there. Yeah, burning some of this conformal coating off. That's alright. As long as it gets off the board, I don't care how. As long as I can free up these solder joints, these board-to-board connections. A little too far there. There we go. You know what? Surfing has always been something I kind of wanted to do, but never really got into. But shoot, if there's electric surfboards, I might have to hop in, you know what I'm saying? I think now's a good time. Might have to join Gote when he comes down to Florida. Nice, we're getting there. We're getting there. Yeah, because these holes are so large, there's such a large amount of solder in them. Takes a while. You have to do multiple passes to clear it out. Honestly, if I did have a solder sucker that I could use, I don't even know if it would be that viable because of how close these pins are to one another. I think we're getting there. I think we're at the point where I'm going to need to use tweezers to get it to move and then hold it away from all the other sidewalls. Man, I swear I just had tweezers right here. Whatever. I got like 80 pair of tweezers. Oh, it's Quail Pig. What game is this? Is it on Switch? He's funny. I really wish I'd learned to solder and weld. Dude, I want to learn how to weld so bad. I don't know if I should be watching all this learning. I can feel the blind confidence building. Oh no. Here, let me put that emote. This is the perfect time to use this emote. This is you right now, taking notes. Hey, Quail Pig. My bad, I missed your comments earlier. This is called, The Struggles of Electric, wait, word of the day? Ultra crepidarianism? Ultra crepidarianism. Overconfidence in areas where you are not an expert because you're confident in other areas. So confidence by proxy, just because, like, hey, I'm good at sewing, so I'm gonna be good at surfing too, or something like that. It's like I can solder, so I can definitely weld at the same time. I like that. Ultra crepidarianism. That's an interesting word. Man, I forgot about words of the day. That takes me back to like school, like bell ringers. Dang, 3 are good. All right, let's get this one. Let's get this off the sidewalls. Crap, it's still on the sidewalls. All right, there's just too much solder in that one. Oh, nice. This one's loose. Crap, there's too much solder. And this one has too much solder. This one definitely has too much solder. I can see it. Okay, I'm gonna have to remove that. You know what? I was talking to a friend of mine or a coworker of mine at work, and I was like, you know how there's simulators for everything? Like there's bee simulator, power wash simulator, farming simulator. They should make a soldering simulator. I feel like that would go crazy. And I was like, yo, let me know. I wish I knew how to code. I'd make it. Because I feel like that'd be a good game. I feel like people would like that one. And it like puts you in a lab with all this equipment. You can see what it's like to actually have a workbench in front of you. And then you can just solder. Some of those games actually do very well for themselves. Better than you would think. Those like simulator games. Oh man, it's annoying when solder doesn't want to vacate the premises. Probably a PCB simulator, component placement station, test station, and solder bench to fix. I used to work at a place that did through-hole PCB fabrication for digital media switchers. Okay. But I was a tech writer and not a hardware guy. Oh, gotcha. That's still pretty interesting though. A digital production company. That's interesting. Yeah, for sure. Definitely burning through a lot of solder braid here. Alright, I think I might be able to move on to another section here. Alright, here's more top-down view. So it looks like 2 of them are being annoying. We have the top rightmost one and the bottom leftmost one, the corners. Right, I'm gonna use my iron that has more heat. Man, it's just not pulling it. I might need to add solder in order to remove solder. Yes, that is a real strat when you don't have a solder sucker. Hey, that worked. Nice. Nice. So, in a little bit, I'll move on from this one, just to get a new angle on something. Nice. Man, it is nice having multiple soldering irons. Right there. Nice. Not nice. Alright, onward. Time is it? Oh man, it's getting to that point. This is definitely gonna have to be a multi-part stream slash repair. I'm so glad I stream on YouTube too, so it saves the VODs. Because Twitch will save a VOD, which is video on demand, but it only saves it for 2 weeks. Because I'm only affiliate. When I was an affiliate, it would only save it for 1 week. Let me get this more in frame. It's these solder joints right here. Here we go. cut off this piece. Also, quail pick, man, it's never too late to learn. Oh man, there goes a roll of solder braid. Could always pick it up, man. Don't let your dreams be dreams. Or something like that. Alright, nice. A little bit of solder on all of them. Man, why couldn't they just use like a connector, man? Why did they have to solder it directly to each board? Like, man. Like, this could have just been a sandwich, like, like a little connector. Kind of like the Xbox controller I worked on yesterday. They could have done that. No, they have the assembly crew put the board, like put the pins through the holes, which is probably a pain in the butt, and then after you do that, you gotta solder it on top of it. Guess they didn't think it was worth the cost of just having connectors. I don't know. Maybe it isn't. Maybe they couldn't find them. Maybe it was during like the part shortages or whatnot. Because that was a real thing. It affected my company for sure. We had to like figure out alternatives. We had to redesign stuff because we couldn't get the parts we needed. Alright. And then we should have 4 pins down here. And you guys can really see some of that corrosion. So this is pretty gnarly. We got this capacitor with a good amount. I think after I desolder these 4 pins, I'm gonna call it a night because it's getting kind of late. Even for me, as much fun as this is to work on, I'm only human, man. I'm not an android. Alright, let's get that in focus. Focus. This over to the left. Alright, that's focused. Alright, we're gonna have to clean this off just like the other ones. Ooh, look at that corrosion, boy. That capacitor is done. I've seen a Nintendo 64 worse than this that still ran after. As corroded as it was, if you plugged it in and powered it on, it still ran. That blew my mind. I never questioned another Nintendo 64 after that. That thing could work being that corroded. Man, today was a good stream. Got a lot of new followers. Appreciate that. That's awesome. And subs. Oh, it's a little bit too corroded. These are ground pins. Oh, that's a pain in the butt. Ground pins are always the worst because they take so much heat to melt. Because it's a lot more copper to melt. So it's a lot more, what's the technical term? Thermal mass to heat up. It's like trying to heat up a piece of wire versus a cast iron skillet. It's going to take a little bit more time to heat up a skillet. It can hold a lot more heat. Wait. If you like the content, hit the like button. If you hate the content, hit it 3 times. Thank you, Quail Pig. I appreciate that. That's funny. Alright, come on, melt. Melt, says me. Make sure I'm trying to be in frame. Let's see. Let me go over to the yeah, I'll go over to the overhead cam and then we shall see if there's anything else preventing us from taking these 2 boards apart. Excuse me. So there's board-to-board connections. Try cleaning this up too. Clean this up again. Okay. Okay, so this pin still soldered in. You know, in movies, whenever I see someone like soldering and whatnot, they make it look so cool and not tedious. Now, granted, do I mind it? No. But like, it's just interesting how they glamorize, like, when Tony Stark is soldering or any other character, it makes it look like, holy crap, they're hacking into the mainframe with their soldering iron, and it's like, oh yeah, that looks cool, but I promise you, it ain't really like that. I mean, like, soldering should not be in PG movies, because that is not the real language used. Now, granted, I don't really curse, so it's like whatever, but still, You only heard what some of my colleagues have said. And rightfully so. I ain't even mad at them. I'm like, I understand. Alright, that one's loose. That one's loose. That one's loose. Not loose. Loose. Okay, so we have this one. So these three are good, and only two on the bottom row are good. Excuse me. Oh, hey. Just trying to free up these board-to-board connections. It's like little bits of solder that are preventing it from being completely released. So that prevents me from trying to separate these two halves. Alright. Oh, nice. It's loose. That's loose. Alright, I'm gonna fill this one up with solder and then try to desolder it that way. This one pin. Pain in the butt. We got 7 out of 8. Alright, just enough to fill it up a little bit, just to take it all away. Sorry if I'm missing any comments. I'm just trying to focus real quick. Why is this one so difficult? It's like the last little bit of solder. I'm telling you, it is so annoying. Maybe that's a sign I should take a break for the night. Maybe that's the sign. Because you do not want to lose your cool with stuff like this. Oh, we got it, baby. Nice. Freaking bastard. Sorry. Shouldn't have said that. Alright, we have all 8 freed up. On that note, I think I'm going to call it a night. This is really cool. I'm looking forward to working on this again. Before I go, I'm gonna clean up, so I'll just be chatting with you guys while I clean up. In fact, let me go to my just chatting screen. I like the synth music, by the way. It's a nice touch. Thank you. I just use copyright-free music, so it's one of the playlists that I enjoyed. Also, remember the Amazon affiliate links for your equipment. You are right. You are absolutely right, Quail Pig. I need to do that. I need to do that. Oh, a necklace. Man, I've had this shark tooth necklace for so long. There's like old footage. You know what? I think there's a picture of me in this exact tank top wearing this necklace at like a park gathering I went to with some friends. And boy, your boy was young. I look so young in that picture, and I was super thin. Holy smokes. Alright, let me go ahead and gather all my mess. Put my mess in the proper receptacles. And just start cleaning up. Excuse me. It's definitely one of the cooler things I've worked on, but we are not done yet. I didn't realize this is going to be like a twofer, man. This is a two-part. This is a two-parter for sure. Go ahead and put this here. You know what? This wants to stay out. I'm going to just leave it like this. Okay. I'm going to vacuum this up. I'm going to keep these tools nearby because I'm going to need these wrenches again. Gotta go to bed. More riding tomorrow. Good night. Alright, Crash. Good timing. It was ending, wrapping up the stream. It was nice for you to join us, man. Always love having you here and hearing about Bolo in the background. One day we're going to get Bolo back in here. Oof, that is a lot of rust. Need to vacuum up. Before I turn the vacuum on, let me collect all the hardware and place it in the proper spot. This baguito. Okay, that's good. I'm gonna vacuum this rust up real quick so I don't mind the noise. Alright, got the bulk of it. Test stand is looking good. Alright. I think we made a good amount of progress. At least we repaired the top board. But that's like the side piece. It's not even the main board that we need to work on. Definitely going to have our work cut out for us on that underside board because there's plenty of corrosion present, unfortunately. And then we still have to repair that connection where the rust was present, which we saw. So this is going to take a little bit of doing. A lot more doing than I initially anticipated. I think both me and the customer initially anticipated. But I still think it can be done. music with AI generators and create little music videos out of my stream gameplay footage. Keeps me away from copyright. Oh, I didn't know that. I might start doing that. AI generators? Because that's the only concern is like, I know so much music and I want to use it, but I don't know the copyright laws. I just don't want to get involved, so I just stay away. Maybe at some point I'll figure it out and then start using, more well-known music. But honestly, for my kind of stream, I don't think it really matters. Because I don't think people come for that. Maybe if I was a React channel or something like that, and I could do that in the future, but right now, no. I'll have to figure something out. But alrighty, everybody. Today was a good stream. It was a very good stream. We got 5 followers on Twitch, 1 sub on Twitch. Had a lot of good people show up, like Quail Pig Gaming, my dad, and everybody else. Spectator 50, he was here. Crash was here. There's a lot of people were here. Good night. Until next time. Yes, sir. Oh yeah, he's using his sub emotes. That's what's up. But alright, everybody, thanks again for joining in. It's getting late. I'm at my limit. Not like a hard limit, but just to keep myself fresh and go into it tomorrow with like a fresh set of eyes and a fresh mind. But alright, everybody, thanks for joining. We'll catch you guys on the next stream. And stay tuned for what the pack does next. Peace.